Right. Okay, hello everyone. Hello again. It's been a while again. My name is Ian McLaughlin, and I am a neuroscientist. I got my PhD in neuroscience from the University of Pennsylvania a while ago now. Time is like totally zoomed past me. I don't know about you in the era of COVID and everything else. Yeah, it's been pretty rough to try and adapt to life in we have a new apartment. We're in a sort of quieter part of town, so the baby can be a baby and have space to be a baby outside of the apartment. Yeah, I think I'm going to be starting a new job very soon. Well, in like a month, almost exactly a month. Whoa, yeah, a day under a month, which is pretty crazy. So yeah. Okay, where is racism triggered in the brain? I had a feeling some topics like this might come up. There's no part of the brain that's like a racist spot, a center of racism. It emerges from sort of a conspiracy of a bunch of different brain regions that are involved in social interaction. So you will inevitably, like if you're trying to map out which parts of the brain are almost certainly involved in racism, and I'm sure those projects have probably been done, to some degree of success. You'll see parts of the brain like the amygdala, like the insular cortex, probably like the fusiform gyrus, like parts of the brain that are associated with like visual recognition, visual processing, but then also aggression, fear, and in some cases certainly disgust, which is why I brought up the insular cortex. But then of course there will be other parts of the brain that are also involved in like future planning, concern for your in-group, for your kin and ken, so areas like the prefrontal cortex. So it's not going to be like it is exclusively the amygdala. That's why we have racism, and so if you were to just lesion that part of the brain, it would be gone. That's not really how the brain works ever, but certainly not, well, almost certainly not when it comes to racism. What else is interesting, or there's been some research that has identified like how dominant a role certain genetic components of who we are, like for example your skin pigmentation, right? Your how much melanin you create. There's been some research that shows that we sort of like dramatically overemphasize those characteristics when trying to assess how similar somebody is to you. So to make it a little bit more practical, so seems like there's something wrong here. Oh yeah, that's terrible. Let's try that again. Okay, let's see if this works again. I got cut off speaking about racism. I should reintroduce. So my name is Ian McLaughlin. I fairly recently finished my PhD in neuroscience at the University of Pennsylvania here in sunny Philadelphia. I'm in my new apartment, or our new apartment, in an area of town that's a lot calmer, let's say less dense, so the baby can be a baby and have more space to be a baby safely. And so actually, I don't know if you can see it behind. No, you can't really see it. Good to see you too, Callie Q. Yeah, we're fortunate to have another pretty nice view of the city. Good morning, Ian. How do our brains perceive pain? Okay, yeah, and I'm sorry for the person who brought up racism. We can talk about that again, but if you're not in the room, then I suppose it wouldn't be viable. So pain perception is actually a very complicated phenomenon, which is part of the reason for why it's so difficult to treat effectively. We really don't actually have highly effective treatments for pain. Of course, the first thing that probably comes to your mind, like we have a treatment for pain, and it's opioids, painkillers, and they are very effective at moderating certain like kinds of pain. But there are, pain. You can sort of break it down into, let's say, two domains of pain. The first is like the pain that you feel when you step on a Lego, and believe me, I know that pain. That's a sharp pain, and actually there are components of how you react to that don't even involve the brain at all. Like it'll just immediately induce a reflex, like a true reflex that's mediated completely by the spinal cord. Brain doesn't even get involved to withdraw your foot from the Lego or thumbtack or whatever it is that you're stepping on. Surprisingly. But then there's the sort of the dull, aching, beating pain from like a bruise or even like a broken arm or something, broken bone, when it's just sort of there being broken and you're not messing around with it. Or a toothache. That's another, form of this. And those types of pain are actually not sent, those signals are not sent to the brain via the same mechanisms. They're like literally different cables that transmit those signals from the body to the brain. And there's even, nuances when it comes to all those different signals, but you can break it down in those two things. So opioids are not very good at treating, they're not very good at treating either, but particularly chronic pain. Opioids are actually pretty bad at treating them because we become accustomed to opioids so quickly. We develop a tolerance and a chemical dependence, and obviously, in many cases, an addiction. So pain is complicated. Pain arises from, a variety of things. At the most, minimal level, we have receptors, sort of like how you have photoreceptors, touch, sensory receptors. You have pain receptors called nociceptors. Think obnoxious nociceptors. And those receptors, different kinds of them, but they can be triggered by different things. So, for example, inflammation. When you get a bruise and it hurts over the long term, it is nociceptors that are being activated by the inflammation that you see from the bruise. So that is the primary mechanism by which pain gets transmitted to the brain, is these receptors are activated. And so as a result, because so many different things can activate those receptors, and that system, as I said earlier, isn't just one system. It's a bunch of different systems all sort of collaborating to make you feel pain. You can attack pain by relieving the inflammation. So, you have a bruise. A bruise isn't really quite the right example. So, for example, back pain, right? A back injury. There can be inflammation occurring in the spinal cord that impinges upon your sensory nerves. And so if you can, alleviate that inflammation through the use of something like steroidal injections, anti-inflammatory steroids, then you can relieve that pain signal. Another is to use the endogenous opioid signaling system, give somebody some opioid drugs, crank up the volume on that signal, and those biochemicals do regulate how severe the pain is. But as I said, there's a bunch of problems with that. But then, so for example, for migraines, we actually don't know precisely what causes all of the different kinds of migraines. There are a bunch of different kinds of migraines. And we don't have treatments for all of them. But one of them, for example, is just the size of blood vessels impinging upon nociceptors, those pain receptors. One can be just inflammatory signaling that just seems to be happening for some reason because you're just so devised. And so you can alleviate that inflammation. So the point being, pain is a very complicated phenomenon, and there are a lot of people in neuroscience working on developing much better treatments than we have right now. But that is the overall landscape of pain. All right. Do opioids just turn off neurotransmitters in the meantime? Not quite. But that's not a terrible way to think about it. So really what they do, so imagine like the level of pain you're in at any one moment as a tug of war, okay? One side is pulling, one direction, another side is pulling another direction on a rope, for anybody that's not familiar with tug of war. And so all of the different people on the teams on either side of that tug of war are different neurotransmitters that are constantly being released and inhibited and activated, and depending upon who's winning, which side is winning, you will either feel more or less pain. And so giving somebody opioids just sort of boosts up one side of that rope, one of those teams, to make it better, make it easier to pull in the away of pain direction. However, the reason I said it's not a terrible way to think about it is that because one of the mechanisms by which opioid drugs do that is by inhibiting the release of some neurotransmitters. Really, it's actually more the inhibiting the firing of certain neurons. But it's not quite like shutting off a neurotransmitter. It's more just like this sort of this debate, this argument between two different sides of just how in pain you are. It's an interesting question. Can you explain the brain damages due to kicks in MMA or boxing? Sure. So yeah, MMA and boxing would fall under like a pretty similar category, which is chronic. Well, of course, there's concussions that you can get from being knocked out. which definitely happens a lot more frequently in boxing or MMA than pretty much any other sport. But then there's also just the recurrent subconcussive head injuries, right? So particularly for like MMA fighters who are strikers, that's the goal. The goal is to jostle the brain around just enough for them to stop being able to sustain consciousness. And then you win, right? And so when you're watching somebody like, I don't know, Conor McGregor, or somebody who's, I don't know, primarily a striker anymore, but, really relied a lot on boxing. That's what you're watching. You're watching this negotiation between these two people, and Conor McGregor's primary arguments are, I'm going to hit you in the head hard enough so that you don't stand anymore. That's not all of MMA. Just for anybody that's not familiar, there's a lot of like submissions and stuff like that. Boxing is exclusively, can't even use any other weapons, so it's just hitting somebody in the head enough times so that their brain can no longer sustain consciousness. However, you don't always just get one of those big giant hits that just knocks somebody out. In fact, that sometimes doesn't even happen in a match, right? And so what you're seeing is just the subconcussive. They're not generating obvious concussions, but they are injuring the brain, right? They are, if you're getting hit in the head and you accelerate at a certain level, your brain is going to be affected. And so in that sort of category of, head injuries associated with athletics, that's more like football, for example. People get knocked out in football too, of course. Let me tell you from personal experience. But rather it's just these chronic, it develops into a condition that's actually a little bit more contentious these days called chronic traumatic encephalopathy. There are now physician scientists who argue that's not actually a thing. That shouldn't be recognized as a distinct condition. But there are a lot of biomedical scientists and physicians who argue, yes, indeed, chronic traumatic encephalopathy arises, here's what it is, when you have those regular, recurrent, subconcussive hits to the head. And what happens, the reason that, I think his name was Dr. Amalu, characterized it as a unique condition is that these consistent lesions arise in the brain, can be seen in the brain. And this was, this was evidenced by the status of the brains of several football players who committed some atrocities, some very violent atrocities, and they had a very, very widespread distribution of these lesions. Now, I have to say, I don't think that we have a great idea of how it is that those subconcussive injuries to the brain actually give rise to these lesions, but it seems to be the case that they do. And so the reason, it used to be called pugilistica dementia, so fighting dementia. So it was originally, it's been sort of recognized among boxers for quite a while now. It was more recently associated with football. And it was just like, and there are statistics that show this, the longer somebody has been competitively boxing, this isn't like, boxing exercise, this is like bouts. The greater number of bouts somebody has had, the more severe their symptoms of pugilistic dementia or CTE will be. So yeah, that's pretty much the landscape. Okay. Oh my God, this woman, someone mute her. Who's the woman? It's okay, people, oh, I see. Is it possible to download human consciousness onto another device? So the short answer is yes, but the longer answer is theoretically. We can't do it now, but we're not even close to being able to do it now. However, the brain, consciousness, human consciousness, obeys the laws of physics just like everything you see in your environment. There are a lot more laws at play, or a lot more instances of the laws playing out in the human brain than most other systems. And there's a much wider variety of what those interactions are like between molecules, between genes, between proteins, between neurons, between regions of neurons. And so as a result, the complexity is so great that it's not just like downloading all the data from a hard drive, which is very, meticulously laid out, very organized. The computer knows where every little piece of data or every datum should be. Not the case in the human brain. But it does obey the laws of physics. And so, we are very good. We humans, one of the things that we're good at is manipulating the laws of physics to achieve some intended outcome. And so, yeah, once we develop computational power that's sufficient to accommodate the complexity of the human brain, I've never seen any convincing argument from a neuroscientist, from a technologist, or from a neurophilosopher. Neurophilosophers tend to be like the last holdouts on this whole, like, we will never download the human brain or be able to replicate the human brain. I've never seen a convincing argument from them either that we'll never be able to do it. Okay, so I'm trying to see this. All right, we'll give it a shot. This could be a troll. We shall see. We're having somebody call in, for anybody that's not familiar with this platform. Okay, looks like we're connected. What's your name and where are you calling from?
I'm calling from Saudi Arabia, and my name is Omar.
Okay. What's on your mind?
I have a serious question for you, sir. I've been watching you for a long time. Nowadays, with the hot environment or the weather is very hot at our region, and my brain sometimes I feel it's boiling.
I see. Yeah. Well, so I haven't ever visited Saudi Arabia. I did visit the UAE before, and wow, does it get hot? It's wild. And so I imagine that's similar.
I work in business and contracting. So from once at the morning time until once I reach home, I feel my head boiling with some kind of very bad pain.
Well,
it's not a headache. It's a different thing.
I understand. So, I mean, to begin with, it's very unlikely that there's actually what you're describing as boiling happening in the brain. That's if that were to be the case, you wouldn't be around to tell us about it, if you know what I mean. And so, but I mean,
I couldn't hear you, so.
If there was truly boiling fluid in your brain, you wouldn't be able to survive that the first time. So that's definitely not what's happening. But that doesn't mean that what you're describing isn't real. Heat, particularly the extreme heat that people experience in areas of the world like Saudi Arabia, definitely can induce headache, can induce dehydration, and all of these things can absolutely result in very severe pain. You can have a heat stroke. Essentially, you can lose consciousness. And so, I mean, I know just from the folks with whom I've interacted from the Middle East, basically you spend no time outside. If you do whatever you can to eliminate or minimize the time you spend outside. But another thing that's important to keep in mind is that you really do need to drink a lot of water, because one of the ways that your brain confronts this extreme temperature is to use how much water you have in your body to try and lower your body temperature as efficiently as it can. And there's only so much it can do, but as a result, you are losing a lot of water. So that would be the number one thing I would consider. But then also, you could have migraines or something like that that are exacerbated when you're in extreme heat. And that could be something that you could go to a physician over and ask, hey, I have these headaches only when I'm hot. Or I know, I understand.
It's not a headache, sir. It's not a headache.
Yeah, I
maybe can we find a way to communicate personally, because I have a case in my brain. I have a very serious case that you might help me.
Okay, yeah.
Electrolytes. I do drink a lot of water, and with the coronavirus today, we have some procedure when I go to any mall or any shop. I go to them and I feel a very bad brain pain, but it's not a headache. It's nothing like a headache. And once I go to to check, when I go to the mall and check my temperature, they say it's 35. How come? And I can see that my brain is boiling, not boiling. It's what do you call it? Some steam comes up.
Huh. Well, I mean, listen. Yeah, I guess we're having a sort of a language challenge here, and it's not your fault. Certainly, there may not be an adequate word in English to describe what you're experiencing. But listen, I'm on Twitter. You can DM me. I have the same handle on Twitter as I have here. And I'd be happy to chat. Maybe we can arrive at somewhere a little bit more intelligible for both of us.
I work in contracting and as a businessman. So once meeting and you have to manage a lot of stuff.
Yeah.
So I feel that, but once everything is going smooth, I feel alright.
Oh, okay.
Maybe I think too much.
Stress, yeah, absolutely. That absolutely can bring about. The only word I have at my disposal to describe what it sounds like you're saying is a headache. I understand it's not the same, and I'm sure that there are meaningful differences. But yeah, reach out on Twitter, and maybe we can get we can understand each other a little bit better.
Thank you very much.
Thanks for calling, man. Yeah. So there was I went to Dubai with some friends. It was actually with a student group, and there was one moment where we went out to what's called the empty quarter, I think, which is like the sort of part of the giant area of Saudi Arabia that's like all desert. It's absolutely gorgeous, but so incredibly hot. And actually, when you sort of looked around, you could see like the skeletons of animals that like clearly didn't make it through the heat. It's wild. I mean, it is something else. So yeah, the heat there is no joke. All right. Could dehydration cause headaches? Yes, absolutely, for sure. Okay, why do when a fighter get knocked out, it becomes easier for him to get knocked out again and again? Yeah, it's an interesting dynamic, right? And in fact, that's true for concussions as well. So, I mean, what you're seeing when somebody's knocked out is a concussion. But yeah, like that's why it's always advisable to stop doing whatever activity you were doing after you've had a concussion. Advice that I did not follow when I was in high school and played football. Because once you've had a concussion, you are far more likely to develop another concussion, even at like a lower sort of force impact. And I've never seen like a description of why that is, like a mechanism that explains why that is. So I'm not sure, but what I can tell you is that what you've noticed is absolutely true. Okay. Feel free to call back in. Sorry I missed your call. You have seizures all the time. Oh, geez, I'm sorry to hear that. I hope you're seeing a doctor. You were diagnosed with a brain tumor, and you have seizures all the time. Geez, I'm sorry to hear that. That is certainly one of the symptoms of developing a brain tumor, is that you can, unfortunately develop epilepsy. Another, by the way, on the topic of head injuries, that is also a way, once somebody has a severe head injury, they can also develop epilepsy. Or develop seizures, and it's going to be different for every head injury. But what you can imagine happening, as I was using the sort of tug of war model for all the competing sort of signals within the brain that determine whether or not you're going to be in pain. If you have a severe enough head injury and you've removed one of those players, one of those tuggers on one side of whether or not you're going to have a seizure or not, you can be more likely to have a seizure. Okay, we are getting a caller. CK, let's see if this works. So CK, it sounds like we are connected. What's your name and where are you calling from?
Yeah, my name's CK. I'm actually in Orlando, Florida.
Awesome, CK in Orlando, Florida. What's on your mind?
Yeah, so I had two questions really, but the first one, so if I drink something, anything with aspartame in it, I get a headache and like 5 minutes later, a gnarly headache like I didn't drink a cup of coffee in the day, and it doesn't go away till I go to sleep. Somebody can give me, I thought maybe it was a placebo effect or something, but you can give me two different drinks, one with sugar, one with aspartame, and I can tell you within 5 minutes which is which.
Wow.
What's that all about?
Yeah, well, so I can't tell you specifically why aspartame itself. Aspartame is essentially an amino acid, if I remember correctly. So something that we definitely know about how aspartame interacts with certain people is that some people seem to be genetically predisposed to be able to taste the difference. It has like a much bit more bitter taste than it does in other people. Right, and so somebody's bringing up the cancer in rats argument against aspartame, and that it's kind of difficult to translate those studies to humans, because what they were doing in those studies is like just pumping these animal models with such high concentrations of like aspartame that you would never ingest that amount of aspartame as a human, or as a normal person. So I mean, it's theoretically possible that perhaps aspartame can break down into something that is able to gain access through the blood-brain barrier to the brain and interact with neurons. But frankly, I've never heard of like severe headaches being brought about by aspartame. That's interesting. Can you taste the difference as well?
Not really.
Huh.
I can taste it probably after about a minute and a half, maybe. I can taste that aftertaste, but as I'm drinking it, no. Like I said, I mean, here down in Florida, a lot of people drink sweet tea and stuff. And
Yeah.
barbecue sauces, and if barbecue sauce even has it in it, I can eat it, tastes great, but 5 minutes later, my head's just throbbing.
That's interesting. Yeah, well, I'm going to look into that because I never heard of like severe headaches from aspartame. I bet that there's something there, that I could speculate on if I knew a little bit more about the biochemistry of aspartame. But you said you had a second topic?
Yeah, it's might be controversial, but what is your opinion on Donald Trump's motor coordination lately?
Yeah, so I assume you're bringing up there's a video of him like walking down a decline. I think he was at like a military event, and he seems to be walking very carefully, very intentionally, I guess one might say, more charitably. And then towards
more so, it was more of his right arm. I think it was his right arm or his left arm, whichever. When he was trying to drink the glass of water, he had to get his other arm to help him. Yeah,
there have been a few videos of that too. And so, I mean, so he's a lot older than I think a lot of people understand. He's at that time in life when, your brain and body stop sort of obeying you in the way that it used to. It doesn't necessarily mean that there's anything else that's wrong, right? However, and this is speaking more broadly. I can't tell you really what's going on in the brain of Donald Trump, right? And he's like a singular kind of guy, right? So there's gonna be a lot of things about his makeup that'll be unique. But speaking more broadly, those types of motor coordination challenges can arise from a variety of things. It can arise from a stroke, of course. It can also be a symptom of Parkinson's disease. It can be a symptom of dementia. And so there's a wide variety of things. And it's because, all of these systems interact with one another. And so for the reason that I go straight there is that I studied a part of the brain where all of these signals sort of are integrated. Mood, cognition, memory, and motor output, like deciding to go do a thing, with action. And so, when you damage one thing, it can have an impact on another, but these are also distinct systems. And so if you just damage, there are plenty of people who have had strokes, even minor strokes, where they don't have as much coordination in one arm, one leg, but they're totally cognitively there. And so all of this to say, like, wouldn't be outrageous to speculate that something has happened with him over the course of his life, not even necessarily in the last 3 or 4 years, where, it's just a little bit more challenging for him to, walk with one leg than the other or whatever. I mean, that would put him in a very big category of people at his age where these types of things happen. But, more specifically than that, I don't think it's responsible or ethical to sort of speculate at that level.
Gotcha. All right, well, I really appreciate your time.
Yeah, I'm going to look into aspartame. Thanks for calling in, man.
Absolutely, thanks.
Yeah, he's 74. I think he's in his mid-70s. And, that's not super old or anything like that. But, if you speak to an actuarial or, speak to a physician, it's just like, if you are admitted to a hospital and you are that age, a different set of possible maladies will come to mind first than somebody who's in their 20s or 30s. Okay. What does thinking too much about non-essential things like worrying about people judgment due to the brain? Yeah, that's a super interesting topic. So first of all, it is a very normal human dynamic to worry about what other people think about you, right? We are, one of the things that is most human about us is that we are highly social primates. And therefore we care a lot about how other primates are perceiving us, and sort of social hierarchy concerns and stuff like that. As accurate as that may be, So it's normal to care about that, particularly if you're in your adolescence. So people will always tell you don't worry about what other people think, and it is generally a good piece of advice, but it's also probably an impossible piece of advice to accomplish successfully. So, but if you are ruminating, like if it is dominating your day and all you're worried about, all you're thinking about is like, somebody looked at you with a certain face and now that's all you can think about, those are symptoms of anxiety-associated conditions, where, you can be predisposed to literally, perseverate or ruminate just spend, be sort of caught in a cycle of cognition focused on one specific, usually aversive or sort of emotionally negative concern. And that's a symptom of social anxiety. It's a symptom of depression and generalized anxiety disorder. But, I mean, I don't know if you're in your adolescence. If you are, then that is super common, and it's probably not prudent to pathologize that. This is a time in life, and if you're not adolescent, just give me, humor me for a second. This is when the time of your life when that aspect of how you interact with other people is becoming calibrated, right? You're getting inputs, social inputs, and you're responding with the bits and pieces of life experience that you've had so far. And, as time goes on and your predictions of what people thought about you are compared to what they actually thought about you, or the evidence of what they actually thought about you, that'll be calibrated, and you'll get much better at, allocating a more optimal degree of thought to it. What do you do about it? So, I mean, I'm not a therapist. I'm not a psychologist. All I can speak to you using is, the perspective of a scientist who studies the brain. What I would do, what I did when I was a teenager who ruminated too much, was I just occupied myself with other things, right? Give your brain something else to focus on entirely that just totally captivates your mind. For me, it was music, playing in a band. It was sports, and that does sort of become problematic if you ever do performances. But the goal is to, if all your brain is left to is, rehashing the previous day's experiences, that's what it's going to do. It's all it's learned to do. And as humans, we are predisposed to emphasizing negative idea, or let's say aversive or negative emotional processes, fear, anxiety. We are just predisposed to worrying about those things for good reason. It was probably evolutionarily quite beneficial for us to do that, rather than be like, oh, I don't see the tiger anymore, or the lion anymore, so who cares? It's probably not around, right? My bit of advice, and it's mostly just advice, is occupy the entirety of your brain with something else. And not only will it probably yield benefits for this concern, but you'll probably become good at something else. Is LSD bad for the brain? It's an interesting question for anybody who's not familiar. LSD is a psychedelic hallucinogen. I think it's arguably the psychedelic hallucinogen. It's probably the most famous, or at least it has been. Maybe seconded by psilocybin in magic mushrooms, and then maybe these days DMT, I'm not sure. But so LSD, so DMT, psilocybin, actually even mescaline, most of the other psychedelic hallucinogens, of which you've probably heard, are much more similar to each other chemically, in terms of chemical structure, than, than LSD. So LSD is sort of in a class of its own from the perspective of its chemical structure. However, despite that, their neurochemistry or their neuropharmacology is actually very, very similar. So they all essentially, like, I don't know if this is like a formal neuropharmacological definition, but it might as well be. To be a psychedelic hallucinogen, you have to interact with the serotonin signaling system, and the dominant focal point of that activity has to be the 5-HT2A receptor, specific serotonin receptor, that regulates a variety of sensory activities, cognition, memory, mood, even dreams, and that it is because all of these psychedelics interact with that shared point in the brain that they induce very similar, not identical, but very similar effects profiles, right? They tend to not induce effects that we would associate with like alcohol or nicotine. They can all have sort of like little moments. They can induce little moments of those types of effects, but the broad effect portfolio is shared because of that convergence on the 5-HT2A receptor. So, is LSD bad for the brain? It really depends on how you're defining bad. As a neuroscientist, I would define bad as anything that damages the brain, that either kills neurons, disrupts connectivity between neurons, damages axons. That's in my definition. That is the thing that is bad for the brain. But that's, one could make a very strong argument that any chemical agent that causes a person to take on some kind of psychopathology, like develop psychosis, develop an anxiety disorder, develop schizophrenia, that is also bad for the brain. And that's a very strong argument. I could be convinced of that. And so LSD is in a category of drugs where that can happen, where, somebody can develop an anxiety disorder or can develop psychosis. And so it's kind of difficult to know whether you're in that category of person who is at risk of that happening. The vast majority of people, so let's speak, so we have to speak in generalities, right? So the majority of people, LSD will not induce this effect, will not cause somebody to develop a disorder of some sort, or anything like that. So by and large, no, it doesn't damage the brain in either of those ways. But I think it's always important to emphasize that there are people, and there's no good way to know if you're one of these people, who are vulnerable to developing these psychopathologies in response to just one exposure to psychedelics. But I mean, to put this into a broader context, I mean, is alcohol bad for the brain? Yes, it's bad for the brain. It is bad for the brain in that first way that I was describing, where it actually damages brain tissue. But it's legal, and you can go right now. Well, not right now, I guess, but in the era before COVID-19, you could go to a liquor store, get enough liquor to literally kill yourself. Okay, I mean, we tried prohibition in this country, and it did not go well. Ask Al Capone. Is nicotine bad for you? Nicotine itself, there's some components of it that are like bad in that first category, not because it damages the brain, it does not damage the brain, but because it can be associated with cardiovascular pathologies, so, life-threatening potentially. Tobacco itself, bad for the lungs, for sure. It's actually bad for other tissue in the body as well, but and you can go actually right now and go purchase enough tobacco to smoke yourself into an early grave. And that's still legal. I don't think it's ever been prohibited, actually, in this country. So, you ask this question, I try and give you as accurate an answer as I can, but I always think it's important when we're talking about drugs to appreciate the broader landscape of how we make decisions about drugs as a society. The United States of America is just one country, but a lot of countries sort of do so in a very similar way. When we say that, yes, there are some potential problems with LSD that are unique, but they're not super common, and the same could be said for, opioids, for example. There are people who are genetically predisposed to developing an opioid addiction. Most people are not, but there's a very large number of people who are. And so those are still legal. They have to be prescribed, but they're still legal. And I should also note, final thing, I'll get off my soapbox here, is there are clinical trials using psychedelics to clinically confront certain psychiatric conditions. And they're showing some benefits. So, end Claritin. I will come after you if you end Claritin. Are those with genetic larger pupil sizes caused by excess dopamine and oxytocin in the brain? Are those with genetic larger pupil sizes? So I guess I'm not quite sure what you're referring to. If you're referring to the, oh my gosh, I'm forgetting the term that David Bowie had. Oh, that's so irritating. It's not heterochromia. It's like diplopia or something like that. No. So you can actually, what was, I have a pretty funny story. So it's not that funny, I guess. But I was sitting in Spanish class and in high school, and there was a girl who was a senior sitting next to me, and she was sort of notorious for partying a lot, right? And evidently the night before she had done some MDMA, which is ecstasy. And we would just chat before class or whatever, and I was like looking at her and I was like, there's something up with your eyes. And she's like, what are you talking about? And then I just sort of looked a little bit closer, and one of her pupils was totally dilated and the other one was totally not. It was just like it made her look like a robot or something. It was so disquieting. And I can't tell you for sure that it was the MDMA that induced this lingering symptom, but it probably was. Okay, so drugs can induce pupil dilation, and it's a fair it's fair speculation. It's good intuition that perhaps dopamine would have some role to play there. However, pupil dilation is not directly regulated by dopamine action. It's actually regulated by cholinergic action, by acetylcholine. But dopaminergic signaling can impinge upon cholinergic signaling and therefore induce that pupil dilation. I understand what you're saying when it comes to oxytocin, I think, as well, because let me know if this was your thought process. So when two humans are around each other and they find each other attractive and they're interested in each other, their pupils will dilate. Not as much as if they're on MDMA, but they'll dilate. And I imagine that in your mind you also acknowledged that oxytocin is quite important for pair bonding, and generally speaking, when you're around somebody that you love or you hope to be able to love, oxytocin will be released. And so maybe that explains why it is that some people might have these dilated pupils. But generally speaking, and I'm not saying it can't be for sure, but oftentimes this discoordination of pupil dilation can arise from a brain injury, can arise from a stroke, can arise from drug use. So yeah. Please install Snapchat. I have Snapchat, and I think I still have it. I tried to use it for a while, and it's just such a pain in the butt. I have Twitter. Like, Twitter for me accomplishes all these goals. I know far fewer people use Snapchat or use Twitter, but I'm sorry, I'm a millennial. My brain doesn't work so good anymore. It's hard for me to learn new platforms. Okay. And my handle on Twitter is the same as on Periscope here. So just drop a line. I respond to pretty much every message. So they used to say we only use around 10% of our brains. Has that understanding of that figure changed? Excellent question. However, it is you are unfortunately you are the recipient of a myth. It is a myth that I refer to as a zombie myth. And I'm sure other people use that term before. I'm not saying that I invented it or anything, but I think it's a zombie myth because no matter what we say in the sciences, talk to any neuroscientist, talk to any scientist, and they will be aware that it is a myth. We are not restricted to 10% of the brain, and in fact, we're not restricted to any percent of the brain. The only restrictions on how much of the brain will be activated at one point is the threshold beyond which you will have a seizure. That is like the limit. And by the way, you can go above that limit and just have a seizure. Okay. So what is that myth based on? Evidently, and we can't be 100% sure, but evidently it is based off of a misquote of, I believe, a Harvard psychologist who was actually describing how much of the brain we understand. And so, unfortunately, that I guess it was misquoted by a journalist there, and ever since then, it is the myth that will never die. Listen, I totally sympathize with why you would believe that, because it kind of makes sense, right? I mean, some humans do extraordinary things, and some humans do totally mundane things or even evil things. If we could just explain why it is that some humans do such extraordinary things by them just cranking up the volume on their whole brain and they have more brain activity, then that simplifies things a lot. Let's just do that for everybody. But unfortunately, that's not the case. And in fact, those people who do extraordinary things, from athletics to music to science to, other things, they're probably not using nearly as much of the brain as you are using when you try and do those things. So if you're trying to play, classical piano, or you're trying to play the violin or something like that, and you don't know how to play it, and you're comparing yourself to somebody, Yo-Yo Ma or whatever, he is probably using a far lower distribution of brain activity than you are, because by developing all that expertise, he's honed in on specifically the minimal parts of the brain necessary to activate to accomplish the goal. If you think about it this way, like, if we were having this conversation in a bar when people still went to bars, and it was just you and me, we're in a room, we're just talking, right? We can hear each other, we can see each other, we're communicating very effectively. Now imagine that there are like 300 people in the same bar, all crammed in together, speaking between us, like their heads are in our way and their hands are moving around us, and we're trying to have they're all yelling, like during an Eagles game or something, all yelling, and you can't even hear each other. That would be it's more like that if we were to just increase the percentage of the brain. It'd be like all those people in the room freaking out and yelling around you, and you wouldn't be able to accomplish the specific goal, which is to have this conversation. Okay, what do you think about protests and the whole cause of the George Floyd death? Of course, I think about it quite a bit. But I'm a neuroscientist. I may be something a little bit different in a day shorter than a month. But yeah, I would suggest that you go talk to people who've studied this, who've worked on it, and understand the nuances better than I do. That's what I do. I turn to experts to help guide me. Caffeine, good for your brain. Oh, and Neuralink. We can absolutely talk about Neuralink. Actually, really quick about Neuralink. I have a podcast. It's called Wired to Be Weird. And we did 2 pretty long episodes on whole brain-computer interfaces using Neuralink, which is Elon Musk's sort of new brain-computer interface company, as the kind of framework. So you can go check it out, Wired to Be Weird. And we talked about it. The titles of the specific podcasts have Neuralink in them. Jeez. Okay, caffeine, good for your brain. Again, just like when people ask, is a certain drug bad for your brain? It depends on how you're defining good or bad. If you're defining good by, productivity, for example, like anything that you can do to your brain that makes you more productive during your day is good for you, then yeah, caffeine's pretty good for you. If you were to, does it induce any kind of long-term damage to the brain that is, irreparable, that the damage will always be there and you'll never be able to recover from it? Does it do that? No, it doesn't. So the cost benefit for caffeine, at least from the perspective of the brain, pretty much favors benefit. It's not the most remarkable drug in promoting productivity. There are drugs that are more effective at doing that. But the costs of those drugs are greater than the cost of caffeine. And when I say cost, I don't mean like the monetary or the money cost. I mean like the cost in terms of like just your overall health during the day, and then your long-term health if you use those drugs over a long period of time. So yeah, and that's one of those. Coffee and caffeine are and tea are like in a category of neuroscience questions that gets asked every single year by multiple people. And so as a result, one group, this is how science works, different groups collect different kinds of evidence, come to different conclusions about their hypotheses, and sometimes they can disagree, and it depends on their methodology. Like, what were they using to conduct these studies? Were they using animal models? Were they using people? Were they not even using animals at all? And they can come to different conclusions, and then from all of those studies, we arrive at something like a consensus. And so, every year you'll see an article that comes out that suggests that, caffeine exacerbates predisposition to osteoporosis in some women. Well, that's not good. Osteoporosis is no Swiss picnic, as I haven't heard that expression in a long time. But osteoporosis is terrible, and so there's that. But then there'll be another study that suggests, actually, caffeine consumption correlates with greater longevity. So you live longer. And so my point being that it's a little bit too complicated to say like it's good for you, you should consume it. But in terms of the cost benefits that we apply to pretty much everything else in our life, the costs really aren't that significant, and the benefits, if you like caffeine, are pretty substantial. Okay. Swiss picnic. We've been locked in too long. Yeah, no kidding. I have a question. I keep forgetting things nowadays. Well, jackpot. I mean, so, that concern, the approach to that concern varies according to age. Just to put it quite simply. If you're older, basically, if you're older, 40 years old, 45 years old, and you're beginning to notice that you're just quite a bit more forgetful, and even things that you never used to forget, like we all sometimes forget where we put our keys or whatever, did we run out of tomatoes, or do we still have tomatoes? Like that kind of thing. We all forget that. That's the frailties of the human mind. But if you're forgetting things like, did I go to work today? Or with whom did I speak at work today? what did I eat for breakfast? If you're forgetting like these types of things, that's concerning. And it's something that you should definitely bring up with a physician. Because what they can do, and it's not even that invasive or anything, they can give you a test, a cognitive test, recently made famous because President Donald Trump, underwent this test. But it's a very simple test. Like, it's not, they're asking questions like, who's the president of the United States? What year is it? It's very simple questions, but they get a little bit more complicated. And then they compare your brain performance to the brain performance of people your age. And it is people your age. Like, that's the sort of the comparison. If you are younger and you're noticing you're still forgetting those types of things, that's also very concerning. But memory can be affected by everything from sleeping hygiene or sleep hygiene, meaning are you getting enough sleep? I know a lot of people are getting more sleep than they normally would now, and so a lot of people are getting less sleep than they normally would, like us. And that can dramatically affect memory. What's your diet like? Are you only eating Hot Pockets, or are you eating like a more sort of competent distribution of nutrients? Have you had a head injury? Right, head injuries causing forgetfulness, that is a very significant concern that you should definitely bring up with a physician. So it's not that age is like the sole concern that you should revolve around, but yeah, it really depends on your age. That reminds me of the misunderstanding that you are either a visual, auditory learner, etc. If people thought about it, they have learned in all the possible ways in some combination. Excellent comment on the YouTube. That is exactly right. So there has been this kind of myth, and I believed it for a very long time, that some people are predisposed to auditory learning and some people are predisposed to kinetic learning was another one that I used to hear, some to visual, meaning auditory learning, like you listen to a lecture and you got it. Visual meaning you have to see somebody write something down or give you a diagram and then you got it. Kinetic was one that I was exposed to when I was, I think, early in college, in my defense, where you retain information more effectively if you are like physically moving, if you're running. And in fact, that's something I did when I was studying for organic chemistry and neuropharmacology, but it was most useful for organic chemistry. It worked. But what Frank C. is bringing up here is that there's actually no good evidence that that's true. And in fact, studies have evaluated whether or not, should we be totally reforming our education system according to whether or not somebody's an auditory, visual, whatever type of learner. And there was this large Harvard study that was conducted, and there's just no evidence that that's true. Rather, it's that, some educators are more gifted at communicating than others. And there's variability in just how students are retaining information in any one day. And so yeah, good. Glad you brought that up. I haven't thought about that for a while. Okay. Also, omega-3 ginkgo biloba and other supplements market improving memory. Okay. Yeah. So on the topic of like supplements, omega-3 fatty acids are really in a class of their own in terms of how like well regarded they've been even by the biomedical community. But in terms of most supplements that are marketed to improve your cognition, there's really not strong evidence that any of them accomplish that goal. And so I only say that because like I am the type of scientist who's sort of cautiously optimistic about a lot of supplements, meaning that just because there's no evidence that they do accomplish a given effect doesn't mean that it's impossible that they could. However, that's not how I think anybody should live their lives according to the maybe, right? Particularly because the vast majority of them almost certainly will not be able to improve memory or, do a bunch of the things that they're marketed to do. So the reason I sort of isolated omega-3 fatty acids in the beginning is because of this, because for the longest time, omega-3 fatty acids were regarded as like, if any supplement is going to be good for you, it's going to be omega-3 fatty acids. And there had been studies that, suggested that there was, it improved memory or it increased longevity. But like I was saying with the types of learner study, there was a gigantic study, or it was actually a meta-analysis, meaning that there was a group in, I believe, Cambridge in the UK, who went through and collected like dozens of studies of, human interventional studies. and basically found there's no effect. Like, they actually don't really do much of anything that's measurable. And this is one of the biggest studies that's ever been conducted. Well, actually, I think it is the biggest study that's ever been conducted on the topic of omega-3 fatty acids. And so, generally speaking, that means it's a more powerful study, meaning that it can make statements that are more likely to apply to you and me than smaller studies. That's sort of, that's not exactly what it means, but practically speaking, that's what it means. So in terms of the supplement industry, now, I should say there are other supplements for which there's some pretty interesting evidence that they do improve longevity and potentially memory as well. And that is nicotinamide ribonucleotide and nicotinamide mononucleotide. And there's a really interesting story behind this whole kind of like longevity supplement thing. It's sui generis. It's like the only example of a company doing what they're doing, where basically they're selling these things as supplements with the sole goal of using the or not the sole goal, but with the goal of using those revenues from those sales to fund studies. So it's an interesting model that's never really been done before. And if you're interested in that topic, I have a podcast called Wired to be Weird, and I think it's the most recent episode. I haven't updated it for a while, but it's the most recent one, I think, on longevity. Check it out. It's a pretty cool story, and it's ongoing, by the way. Like right in the middle of the action is when I dropped in. Okay, I have a question. How will the vaccines affect the electrical impulses of our brain? Okay. If you'll permit me, I'm going to infer a little bit from your question. So in terms of, I think, what you're referring to, in terms of like, will vaccines damage or disrupt neuronal signaling between neurons? No. They can't do that. Like, they don't have the capability of doing it. The vaccines, assuming that they were correctly produced and all of those caveats, right? Because their primary mechanism of action is in influencing the immune system, literally in instructing B cells and T cells, mostly B cells, so that you have an acquired immunity. Now, that's not to say that getting a vaccination doesn't have some effect. No, I'm talking about the chip that will be in the vaccine. Okay, I'm not familiar with that. I'll have to look into that. Yeah. I might as well stop talking now, because like what I was about to go into is not what you're interested in. So I'll have to look into that. I've not heard anything about a chip being included in any vaccine. I think I know what you're talking about. Okay. Yeah. I would want to read up a little bit more on that. My understanding is that chip would not be actually included inside the soup of the vaccine. That it would be another tool. I also don't know that it would be a requirement to get that implanted. It was just one idea for how you could, do contact tracing. But yeah, listen, maybe I'm ignorant when it comes to this, so I will look into it. Okay. Is it true that the left brain, right brain concept is a myth? I love that question. Yes. Yes, that is a myth. It is mostly a myth. So when people say when people are describing themselves as I'm a right brain person or I'm a left brain person, it's not that they're wrong to describe themselves in a certain way, to put themselves in a category of characteristics that they share with other people. Usually what they mean is I'm a creative person, I'm an artist, I think I abstract. I have a lot of abstract thought. I care a lot about literature and art and so on. And then, or they mean I'm a very analytical person. I'm a bit anxious sometimes. I like to take a problem, outline it, break it down, and then go step by step meticulously through it. Those are two different cognitive strategies, and people do tend to have one or the other. But it is incorrect to suggest that it is because one person is a right brain person or a left brain person. Rather, it actually has a lot more to do with, it seems, how anxious they are. Sorry. Trying to hear if my baby's knocking on my door. I don't think so. She can now knock, and she knocks like an adult. My baby is a year and a half old, and it's like, doom, 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 doom. Pretty cute. And then just say like, Daddy, open, open. Very adorable. Even when you're in the middle of like, I'm trying to read this book. Where's the book? Oh, never mind. Anyways, yeah, so it is a myth. However, here's the seed of truth to that myth, which is there are some components of human cognition that are what we call lateralized, meaning that, generally speaking, the brain is a bilateral structure, almost without exception. You have a hippocampus on this side, hippocampus on that side, amygdala, insula. And even like you have a cerebellum right in the back of your brain. Even it is divided down the middle, right? And of course you have the two hemispheres of the brain that make it very obvious when it comes to the cerebrum. However, there are some brain regions where, while there are, it is bilateral, it's not 100% symmetrical, meaning like one side is a little bit bigger than the other, or that one side has a subnucleus, meaning a little collection of neurons that is absent from the other side. And in fact, parts of the brain that I studied for my PhD were that way. And they tend to be older parts of the brain, and they tend to be older, meaning like evolutionarily older, like they've been in some animal to whom we're distantly evolutionarily related for longer than like the forebrain, for example. So the most famous cognitive tool or cognitive function that is so lateralized is language. Language does tend to emerge from a bit more left brain activity than right brain, but it is not exclusively left brain output, and pretty much every single thing you do, whether it's speaking, writing, doing art, or doing math problems and accounting, you're using both hemispheres of the brain. You have no control over it. Cerebro. Where is consciousness? Actually, yeah. Oh, thank you so much for the super hearts. I really appreciate it. And your answer is perfectly applicable. It comes from the brain. And I'll stop being so irritating. I understand probably what you mean is like, where in the brain is consciousness generated, right? We know that there are different parts of the brain. I'm sure you're aware. There's a part of the brain that's devoted to like visual activity, and parts of the brain devoted to memory, parts of the brain devoted to color perception, to like your sense of body and space, right? And just like if you have a computer, if you know anything about building a computer, you don't need every single thing that somebody else has in their computer. You don't necessarily need computer fans. You don't necessarily need to have a GPU. You can just take them out and you still have a working computer, right? That's not quite how the brain works. So there was a study. So I led a recitation of college students in my third year of my PhD. College students taking a neuroscience class. It was an intro neuroscience class, and I thought it would be fun every now and then to preempt them with a question that I bet many of them had wondered, which is from where does consciousness arise in the brain? And I found this study, which was very funny, which was like, that was our goal. They were like, okay, let's, and it's a lofty goal. I mean, it's a totally respectable question, which is like, can we map out the minimum necessary parts of the brain to accommodate the production of consciousness? And they came up with the name for their circuit, and it was something like occipital, striato, parieto, fronto, limbic cortex. It was something like that circuit. It was basically I basically named all parts of the brain right there, and it was just like this like long like multiple hyphens, and it's like I think that the takeaway for that is that like all of the brain is involved in consciousness. If you lose one part of the brain, you're going to lose some component of consciousness. Doesn't mean that you'll lose consciousness. Doesn't mean that you'll not be able to sustain your awareness. But I think people who have sight would argue that vision is a very important part of their consciousness. It guides their behavior. It guides their consciousness. I think other people would say olfaction is very, very important to consciousness, right? It's how you distinguish between a food that you like and a food that you dislike, or it's how you take it from me as a young baby. Your baby smells very good to you as a parent, right? It's like a totally ancient primate thing. I'm sure my baby does not smell good to other people, other adults. Probably just smells like a baby. But to me, it's like I pick her up every time. I'm like, We are primates. It's a very ancient sort of bonding mechanism. And in fact, if you lesion olfactory components of the brains of other animals that are even more olfactory driven than we are, like rodents, they will not parent bond. They smell good until nappy time. Yeah, right. Yeah. So my point being, just because the end result is that is like, so yeah, vision is very important, olfaction is very important, but if you remove the occipital cortex, well, if you remove the visual cortex, you'll still be able to interact with the world. Your consciousness will just be different. But that's the point, is that all of these things collaborate to generate your consciousness the way it exists today. And not all of them are as important as other parts to just sustaining consciousness. If that's what you're interested in, look at the reticular activating system in the brainstem. If you lose that, you're not going to be awake. But the reason that it is so important is that it is a conduit by which signals from the body get to the brain and the brain gets to the body. So yeah, I know that's sort of a frustrating answer to that topic, but it is true. There's a reason that so many neuroscientists study so many different questions about consciousness, because it's very, very complicated, and there's a lot of parts of the brain that participate. Okay, getting a caller. Looks like we're connected. Zanga. Oh, La Sanga. Are brains evolving, changing physically over time? That's a super interesting topic. There's no evidence at our disposal that the brains of Homo sapiens 10,000 years ago, 50,000 years ago, 100,000 years ago would be any different than ours. Would be significantly different than ours, which is very cool, right? That's amazing. Let's just say even 2,000 years ago, right? Long time ago, in terms of, you certainly wouldn't have seen any big skyscrapers, right? Or, a lot of important books to a lot of important cultures weren't even written then yet, right? But there's no evidence to suggest that the brains of those humans were really significantly different from our own. What's changed is social evolution, cognitive evolution. However, it is difficult to be aware of, there are different levels, different substrates for evolution in the body, right? And it's tough to know, is there some kind of gene drift going on in the population about which we're not really aware? For example, are people becoming a little bit more predisposed to hyperfocus? Or are people becoming more predisposed to less aggression, right? It's tough to know because we're not just constantly monitoring, the entire human gene pool. My suspicion would be that no, it's not really that biological physical evolution is not where the action is right now. The action is in the level of the brain. It's in the level of, how quickly we learn now, how differently we communicate with one another, and all of the knowledge that has been produced that we can, enjoy and work with and build on. That would be my speculation. I can't tell you for sure, though. Again, because it's not like 23andMe has everybody's a genome sample. They don't even have mine, and I'm very curious. I really want to do it. I just never been able to afford it. Okay, I need a motorhome to haul my heavy brain. Are dog brains different from wolf brains? Yeah, for sure. Yeah, they will inevitably be. Books you recommend to people interested in learning more about the brain? Sure. There's a couple. So probably the most fun book to read would be probably David Eagleman's Incognito. I think he does a good job. It's definitely a book for people outside of science, but that's great. I mean, I feel like there should be more of those books. But he's a neuroscientist, and in fact, I almost worked with him when he was in Houston on neural law. But then I had to move. So David Eagleman, Incognito. Check that one out. It's fun. The whole point of Incognito is that he describes the fact that we are only familiar with certain aspects of consciousness that are, outside of the hood, right? Most of what drives consciousness is under the hood, right? You look at a car, you don't see what's under the hood, you just see the car. You just see the car driving, right? And so that's his argument. Okay. So so David Eagleman, Incognito. Another really fun book, I think. It's more of like a story, but it's history, called The Tale of the Dueling Neurosurgeons by Sam Kean. That story, first of all, gives an interesting sort of history of the precursor to neuroscience, but really it was the precursor to like modern biomedical science. I'm sure you've seen those beautiful, obviously hand-done illustrations of human anatomy, right? There's a very famous one of like a man sort of walking like this. He's sort of striking a very sort of like Greco-Roman pose. That was done by a guy named Andreas Vesalius. And before him, and that was done, I guess, in like the 1400, 1500s, thereabouts. Before him, the only anatomy that was available to people interested in anatomy was done by Galen, an ancient natural philosopher, I guess, because it was basically verboten. It was illegal to do that kind of anatomical study because you have to study. You have to actually see what's there to get an idea. So The Tale of the Dueling Neurosurgeons by Sam Kean. There's another one that oh, man. Shoot. Well, I can give you... there's a good science fiction... There's two good science fiction books. Or... hello, Leandro. The science fiction, series... No. One's a series, the other one's not. One is called The Nexus Trilogy by Ramez Nam. Ramez Nam was at Microsoft, and he worked on their Outlook system, but then also he worked on their AI department. I didn't even know they had a department of AI. So the Nexus Trilogy, what he does very good or very effectively is it's a very realistic depiction of what being a neuroscientist is probably going to be like in 10, 15 years. Really, and it's a very cool premise. That's one of the better science fiction, the more realistic science fictions I've read in a long time. Another one is Recursion by Blake Couch, I think his name is. And it's a little bit less interesting from my perspective. It's a little bit simpler, but it's a lot easier to approach. It's much more approachable. Sort of a story about memory and all of science fiction, just extrapolating a concept and just running with it. And the extrapolation of recursion is that what if you could come up with a machine that manipulates memory perfectly? Those are the books. Gosh, I'm so frustrated that I can't remember. I Am a Strange Loop is a good one. It's a little bit more technical. Okay. How do I quit cigarettes? Well, believe it or not, you are speaking to somebody who's written several papers about the state of the science for quitting cigarettes. Nicotine is one of the most addictive drugs. Weirdly, because it's also one of the least enjoyable. It's just it doesn't really make you feel super euphoric. It does relieve anxiety for a very short period of time, but then it actually exacerbates anxiety for the long term. So, it's tough, and it's weird that it's so addictive. The best outcomes are, statistically, in terms of how many people have been abstinent from cigarettes for how long, are from using some kind of nicotine replacement thing, like gum, or the patch. They have nicotine lozenges. They used to have nicotine vaporizers, is what they used to be called, e-cigs. The stats on quitting for those is pretty good. Stats on quitting cold turkey, pretty bad. People can quit, but then in terms of how long they're abstinent, it's pretty bad. So, it's worth a try. Pretty much everybody always tries doing that at least once. And maybe it works for you. For some people, it works just fine. That's what my dad did. He went from smoking a lot of cigarettes to nothing. And I should say, there are some genetic determining factors, it seems, according to the data from my lab, from the lab of which I was a part, that suggest that there are genetic determining factors as to how severe your withdrawal syndrome is going to be. So, in other words, practically speaking, some people are going to find it way more difficult to quit than others. And those people, by the way, will tend to also smoke more during the day, started smoking earlier on in life. So there's that. Some of the partial agonists, like varenicline, that has shown some good stats, some good data. And then one of the ideas is to just combine those two things, like use the nicotine replacement, use the gum, use the patch, whatever it is, and then also for a period of time, use a partial agonist like varenicline. The point is, if you're interested in that, like, I guess the point is that nicotine replacement is a great strategy. It's not the only strategy available to you. You should go to a physician. If you've tried quitting and you're just not able to do it, you've tried the nicotine replacement, the gum, the blah, 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 and you're just not able to do it, go to a doctor and say, hey, I really want to quit, and I've tried these things. What can you do for me? And so, yeah, I mean, there are some studies of, what is it, buspirone? Of, not buprenorphine. Oh my God, it's so irritating. What is it? It's bupropion. Okay, so bupropion, also known as Wellbutrin for more people, I believe Chantix for the purpose of quitting, has been used for some people. Has been used by some people successfully. But the best stats come from nicotine replacement and or nicotine replacement with the partial agonist like varenicline. No, not Chantix. So, I assume that you're against Chantix because it either didn't work for you or because you've heard other people talk about it negatively. So, okay, suicidal tendencies. Okay, yeah. So let's talk about this. This is an interesting topic, I think. So first of all, it has worked for a good number of people, right? And so that's just a reality. Like, that regardless of suicidal ideation or anything like that, people have had some success using that drug to quit. So there's that. I mean, and you can acknowledge that and say, yeah, but the risks are still great enough for people for whom it won't work, that, they'll, what was that? There's been a lot of helicopters flying around Philly lately. So, one of the critiques, Wellbutrin or bupropion is it's a norepinephrine reuptake inhibitor. It also is a bit of a dopamine reuptake inhibitor, but mostly norepinephrine. So it's an SNRI essentially, which is in comparison to like Prozac or fluoxetine or Lexapro or Celexa. These are selective serotonin reuptake inhibitors. So they have very similar effects, but on different neurotransmitters. They all affect all of those neurotransmitters, but some more on one than others. So there is a concern that, there is this increase in rates of suicide among people who have been prescribed these drugs. And that is important. I mean, one of the primary reasons that you would use these drugs to try and avoid and treat psychopathology is to avoid suicide, right? To treat depression and stuff like that. But it's important to acknowledge that these are folks, people who are being treated for depression, people who are being treated for generalized anxiety disorder, as well as people who are quitting nicotine. Suicidal ideation is one of the symptoms of all of those things. Suicidal ideation is a major symptom of severe depression, major symptom of generalized anxiety disorder, and a symptom of nicotine withdrawal. So, the reason I say this, and it's not like I'm some shill for the pharmaceutical industry. I will criticize the pharmaceutical industry and the biomedical, relationship with the pharmaceutical industry till the cows come home. And I don't even have cows. So, by no means am I like a defender of big pharma. But what I am is defensive over the tools that people use to improve their lives, to improve their quality of life. I personally know, let's disregard the statistics, right? I personally know people who have used, these SSRIs and SNRIs who were very suicidal. 2 people. And now they're living very healthy, productive, fulfilling lives. So, I think we need to be a little bit more nuanced about this, right? These are people, tragically, who are predisposed to committing suicide. And are, do I think that SSRIs or SNRIs are perfect drugs? They are like the panacea for depression or anxiety or whatever? No, they're far from perfect. But we're lucky we have them, at least then, right? I mean, rates of suicide are increasing in the United States. Rates of, and they have been successful treatments for a lot of people. So that doesn't mean that we should stop trying to find better treatments. By no means. That was one of the main motivations behind the 7.5 years I spent in the lab trying to understand mood and anxiety, because I know there's so much room for improvement. But to just say, like, you shouldn't use that drug because some people who were prescribed it commit suicide, that's just, I don't think you're thinking about the data with enough nuance. How is a brain scientist different from a neurologist? Excellent question. Well, I mean, they obviously have some similarities, right? They're both concerned primarily with the brain or the nervous system. The difference, however, is that a neurologist is a medical doctor, so they get an MD. A neuroscientist is a scientist, and so we get PhDs, or a master's degree or a PhD. Generally speaking, a master's degree is like the first 2 years of a PhD, and then a PhD is what you get at the end. So those are two different kinds of training. So medicine predates science by quite a bit. Medicine was being practiced before science was even a concept. Before Francis Bacon, before the scientific method was devised. There were still people doing scientific-y type things back then, but they were really natural philosophers. They were observing nature and trying to understand it. Science is a fairly new discipline. It's a fairly new tool. And in fact, medicine, it's a fairly even more recent phenomenon that medicine became evidence-based, right? So medicine wasn't always medicine-based. Or medicine wasn't always science-based, and therefore not a lot of medicine was going on. It was more sort of eminence-based. This person has been a doctor for 50 years. They've seen everything. They have the best. Insights for this, the best idea of a cure. So fairly recently, medicine was like, hey, those scientists, they're proving us wrong a lot. And so the difference is that a neuroscientist uses the scientific method to ask questions about the brain, the nervous system, and consciousness, conduct experiments, and evaluate your hypothesis. Try and disprove your null hypothesis. Basically see if your hypothesis was correct about this system. A neurologist uses that information these days and that knowledge, and tries to recognize when something is wrong in somebody's nervous system, and try and solve it, either by consulting with a neurosurgeon who then physically intervenes and goes in and removes the tumor or whatever, or by prescribing some medication because maybe somebody has epilepsy. Thank you so much for the super hearts, you two. Hannah, I really appreciate it. And Patty, thanks so much for the super hearts. That's the main difference. Also, it takes long. Well, no. Okay, it doesn't take long. They both take a very long time, I'll say. There's a little bit of a rivalry between science and medicine. It's a rivalry. It's a sibling rivalry, right? And a lot of it comes from the fact that, as a society, most people outside of science, and I was one of those people, I'd never met a scientist until I went to college. Most people, the only point of contact that they have with science is medicine, is through going to the doctor. I understand. So a lot of people will go to neurologists or physicians to tell them about science, and they have proficiency. I mean, they understand what scientists are doing, but it's just a different kind of training. So physicians are not scientists. There can be such a thing as physician scientists, like Dr. Peter Hotez. He's an MD, PhD. My sister's a researcher and a neurosurgeon. Yeah, so I mean that can totally happen. And there's plenty of collaborations between scientists and physicians. And then of course there are scientists, physicians again who have both an MD and a PhD. But it's just a different kind of training. Just all right. Wish Pharma didn't have so much control in med school. I didn't know that they did. That's interesting. Yeah, I mean, totally. the relationship between medicine and the pharmaceutical industry is very perverse. There's a lot of perverse incentives there. And, again, because physicians aren't, at least historically, haven't been trained to scrutinize scientific studies, they can be a little bit too credulous when it comes to the claims of pharmaceutical companies. Like, for example, Purdue Pharma. Purdue Pharma is going to be the example that we all use now as an example of how the pharmaceutical industry perverted medicine for a long time. Purdue Pharma was the company that sold OxyContin. And OxyContin, and I actually remember this. I was very, very young. I think I was listening to like Loveline with Dr. Drew or something like that. And early on, OxyContin was marketed as a less addictive painkiller than hydrocodone or morphine. Hydrocodone in Vicodin and codeine and codeine. And that is just totally wrong. Like it is a more potent opioid. It is going to be more addictive. But they made these, that's how they marketed it as a less, and hey, I mean, if you're a physician and you have this tool that's available to you that is less addictive to treat pain, oh my God, give it to me. Yeah, I would love to use this with my patients. But they didn't really scrutinize the claims that were being made. So, yeah. Can you give reasons why people troll? I think, okay, I have a theory. I mean, I assume that there's somebody out there actually studying this phenomenon. I think it comes from a place of desperation. This is totally speculation, but a place of desperation where somebody is not receiving the attention, a sort of a satisfying level of attention that passes a threshold that we all kind of have, where, and it'll be different for different people, but like, being socially isolated is damaging. Like it is unhealthy for the vast majority of people. And I bet COVID-19 has kind of exacerbated this for a lot of people. I know some of my friends certainly have struggled through the whole like safer at home, social distancing, that kind of thing. So, okay. So yeah, so I think it comes from, so there's that, right? They're not getting enough, any kind of like positive or negative feedback from their environment. And so as a result, there is this one way that will almost always elicit some social interaction with somebody else and can also dominate the conversation, and that is trolling. Trolling, it checks those boxes. You are getting attention. And I'm sure that oftentimes they have convinced themselves that this is actually what I want. I want their suffering. Like, they're, you mad? Like, I'm in their head rent free. Like, it's that kind of thing. But my bet is that deep down, if they could just get some positive attention in their environment, trolling would not pose such attractive features. It would be like, why would I do that when I can just, go out to dinner with my girlfriend? So yeah, I think it comes from a place of desperation. And that's why I've always sort of like, there's certain kind of trolling that I think is just, it's not even interesting. I appreciate an interesting troll, so I always empathize. Okay, does drinking a lot of water help the brain and neurons? And does COVID-19 attack your brain and damage? That is an awesome question. I'll do that really quick. So, drinking water is important for the brain. Absolutely, you need to drink enough water. You probably are not drinking enough water, or you're probably not drinking as much water as you could for more optimal sort of health. Does it help neurons? I mean, the brain is the most sensitive organ in the body. And because it is so sensitive, it has evolved to be able to regulate its own distribution of nutrients, right? It demands like 20 to 25% of your caloric intake. And it regulates that. Like, it'll make sure that it gets that. And in fact, if it doesn't have enough calcium, it'll leach calcium from your bones to make sure that it has enough calcium. So this is not to say that, like, if you, there's a sort of bare minimum of water that you probably need to drink, and you're probably above that, right? Otherwise you'd feel terrible. But and getting beyond that threshold, that will not be like the thing that you, when you do it, you're like, all of a sudden I can remember things from 40 years ago, or I know Kung Fu. Like, it won't be like that, but it's generally speaking a good idea to drink more water. All right, COVID-19 in the brain.
Super interesting topic. So first of all, we don't know. But we do know some things. First of all, back in China, following the let's say SARS-1, SARS-CoV-1, the initial coronavirus outbreak that caused SARS in the early 2000s. Following that outbreak, some scientists in China did find, let's say, COVID-19 particles. Or no, not COVID-19, SARS-CoV-1, I'll just call it by its name, particles in nervous system tissue. And I think it was peripheral nervous system tissue. And so, meaning that by some mechanism, the virus was able to gain access to nervous system tissue. And that is very extraordinary. Oh no, it wasn't peripheral. I think it was in spinal nervous system tissue. And that's extraordinary because almost nothing is able to gain access to the central nervous system. Okay, so there's that. That's one point of evidence. Not the same virus, though. So SARS-CoV-1, they're very similar. That's the reason that we call the virus that causes COVID-19, SARS-CoV-2, because I think there's something like 80% homologous, meaning like at a genetic level, viruses, all they are is just a series of genes, just a handful of genes. In the case of SARS-CoV-2, I think it's about 30,000 base pairs, which is kind of big for the kind of virus it is, for whatever. But even with that, that is just a handful of genes. And so it's a lot like a computer virus. It's a good reason that we call a computer virus because it's just a simple set of code that basically is devoted to gaining access to a cell, hijacking the expression machinery, the things that express genes, your genes, and churning out more of the viral particles until it pops out and spreads throughout other cells. Okay, so very, very similar, but it seems to be different in some very important ways. So there's the SARS-CoV-1 in nervous system tissue. Another one is that once the outbreak spread beyond China, and most notably it hit Italy and then France, physicians began to recognize that there were some symptoms of the disease that weren't exclusively respiratory. So, if you remember only a few months ago when this thing was first emerging, basically what our understanding was that it was just a respiratory virus like every other coronavirus, right? Where, it has some unique features where you develop this extremely high fever, but most of the symptoms are respiratory. Coughing, shortness of breath, difficulty to breathe, that kind of stuff. But once physicians in like Italy and in France began confronting this, and obviously Italy got really hammered, they started noticing that there were some symptoms that were non-respiratory, meaning like, for example, confusion was one of them. Stroke was another one of them. Even seizures was another one. And I should say that my boss, when I was doing my PhD, she is from northern Italy. She's not from Lombardy, which is like the area of the country that was hit the hardest. She's from the other side of the north of Italy. I think it's called Veneto, where Venice is the capital. So she took it much more seriously than I think a lot of people did at that time, and I also therefore took it a lot more seriously than a lot of people were. But yeah, I actually spoke to her kind of recently, and she's like, yeah, I mean, I've spoken to people, and they're pretty confident that there is some neurological component to this. What it is, we don't know. Okay, and then, so after that, then there was this this acknowledgement that in some people there seems to be a loss of olfactory faculty, meaning people lose the ability to smell or taste, or taste. So that is exclusively neurological. So we're not 100% sure on that because, if you've ever had the flu, if you have allergies, you lose the ability to smell things because your nose is so inflamed. So we're not 100% sure that is a bona fide neurological symptom, but it has been consistent enough that that there's some speculation that it's neurological, that is a neurological symptom. I should also note that in Italy, I think it was in Italy, maybe it was in France, there was a hospital that was getting hit really, really hard, and they even set up an entire devoted ward of the hospital to SARS-CoV-2 neurological patients that had neurological symptoms. Okay, another thing is that there have been multiple instances in Italy, in France, and now in the United States, recently in the United States, where patients came in with neurological symptoms. That was it. No respiratory symptoms whatsoever, no fever. And they go in just because, hey, I'm feeling confused. Maybe I'm having a stroke or whatever it might be. They get tested for for COVID-19 and they test positive. Again, to remind you, this is in the absence of a fever. This is in the absence of any respiratory symptoms, the sort of hallmark symptoms of COVID-19. And so yeah, we go into it a little bit more. There's some interesting biology underlying why it might be the case that SARS-CoV-2, the virus that causes COVID-19, might be able to do this uniquely. And briefly, here's two of them. So one is that way back during the outbreak in China, there was this statistical correlation that was collected between people of a certain blood type and susceptibility to SARS. Meaning that if you had a certain blood type, you seem to be more likely to not only catch SARS, but have a very severe reaction to SARS. And then, MERS came out, and that was sort of a different dynamic that wasn't followed, didn't spread as much. And then there was, and also very, very deadly. But then more recently, it has again been shown that in some areas, there has been a correlation between a certain blood type and catching COVID-19 and having a very severe reaction to it. So you might say, oh, come on, that's like, why? That never happens. Like, we never hear about like the flu being determined by, fatalities from the flu being determined by blood type or really anything else. That would be wrong. The norovirus, which is sort of like the infamous cruise ship virus, which causes this very, very, very severe, vomiting, diarrhea, stomach virus, is sometimes what it's referred to as. It exhibits blood type discrimination. So it turns out that if you are a certain blood type, you are much more likely to not only catch norovirus, but develop a very severe reaction to it. And we actually know why it is that virus is able to interact with certain glycoproteins on blood surface antigens. And so is it possible that SARS-CoV-2, maybe even SARS-CoV-1, exhibit this kind of blood group discrimination? It's possible. We don't know for sure. We don't know a lot. This is a very new virus. So we don't know a lot about its protein distribution, how its proteins interact with other proteins in the human body, but that's possible. Okay, I said I'd give you two potential explanations. The second is that I did say that SARS-CoV-2 and SARS-CoV-1 are very, very similar. I think there's something like 80% homologous, meaning like they're about 80% the same. But what is it in that final 20 or 30% that distinguishes them might be the fact that this SARS-CoV-2 is capable of interacting with different receptor proteins and enzymes than SARS-CoV-1, which may be the case for why COVID-19 is both an upper respiratory virus and a lower respiratory virus. It can infect more of the lung, right? It can infect more, it can infect more of the cells of the respiratory system. But not only that, if that's true, and if we have pinpointed the correct receptors and enzymes, by the way, when I say receptors, the way a virus infects a cell, there's a bunch of different ways, but one of the main ways is that it binds to a receptor. It can be like even a neurotransmitter receptor, binds to it, and then that the cell that is hosting that receptor internalizes the receptor, and then the virus has access. It's sort of like a Trojan horse. So if we have identified the correct receptors and enzymes with which ACE receptors, yes, exactly correct. Yeah, you've clearly read Ed Yong probably, right? But it's not. It's also furin. So it's not just the receptor. It's also an enzyme that's involved in basically gaining access to the cell. Hey, what's up, Zach? Oh my God! Sorry, you came in a very intense moment. Good to see you, man. Hope all is well. So if we have pinpointed the correct receptors with which SARS-CoV-2 interact, then not only are those receptors very, very prevalent throughout the respiratory system, but rather throughout the rest of the body. And so that might be part of the reason for why not only do some people develop, very, very severe respiratory reactions, upper respiratory viruses tend to spread a lot more easily and they tend to be less deadly. lower respiratory viruses tend to be much more deadly but spread more with greater difficulty. And it seems that COVID-19 is both. And so that not only might explain why it's both, and that also would be why it's so contagious and why it can be so deadly, why we've had over 100,000 fatalities in the United States alone, about 500,000 fatalities worldwide. That is that is insane. If you were to tell me, even me, I was taking this very seriously, that this is what we were going to be dealing with in January and February, which at that time, our family was already practicing physical distancing, I would be shocked. And so yeah, if you think this is a hoax, I don't know what to tell you. Like, you are disregarding the tragedies that over 100,000 families has had to endure. You don't care. You just think that it's this big conspiracy between that number of people, the number of interviews that they've done of people who not only can never speak to their relative again, ever, because they're dead, but also when they tested positive for COVID-19, that was the last time they got to see them. They didn't even get to say goodbye. They didn't get to have any kind of funeral or anything like that. So I mean, I'm sorry. Like, I understand that there is a conversation to be had about the stringency that we apply to data collection, but over 100,000 is over 100,000. Okay? Maybe some of them, it is absurd to suggest, oh yeah, but that person also had diabetes or whatever, and they just died from the diabetes. Like, that is a misunderstanding of biomedical science that is just, it takes such a level of arrogance that when I hear certain people, prominent people, talk like that, it's like, it's unfortunate that somebody can to rise to such prominence and be so arrogant. So sorry, Zach, it's been a while, man. Sorry you came in, you had to see me like this. but that it is that ability. So those two things, right? The first is potentially blood surface antigen, blood group discrimination, and then also this potentially new ability for the virus to interact with more proteins than SARS-CoV-1, SARS. Okay, fascinating. I heard my second grand mal seizure within 3 months of each other in the beginning of March, and one a few weeks ago, wondering if I had COVID. Epilepsy does not run in my family. Oh, wow. Yeah, I mean, frankly, we don't know enough about the pathogenesis of COVID-19 to know for sure. All we have right now, it's still like, it's only been a couple months. It feels like it's been an eternity, but it's only been a couple months, so we don't really know a lot about the biology. Basically, we're limited to the observations of physicians, which is super valuable, don't get me wrong. But, again, there's a difference between a scientist and a physician, and they're busy trying to save patients. By the way, like, I have a friend who's an emergency room physician, and she's pregnant. She's beginning to be visibly pregnant. And she's going to have to work well into her pregnancy. And, she has verified, like, all of the other physicians that in certain parts of the country, not all parts, certain parts of the country, they have gotten down to, like, one clean respirator. And, that would mean that if there was one more patient, somebody was going to die. And if you think that my friend, who's a physician, not at a big hospital, they don't work at, I guess it's a she because she's pregnant, but she doesn't work at, like, Penn Hospital, HUP, Hospital University of Pennsylvania, or CHOMP, or any of these giant big, temples to medicine that have been erected. She works at a small hospital, and she's their ER doc. And if you think that she is in on some kind of conspiracy, I mean, you are telling yourself fairy tales. Like, you are speaking to yourself like a baby. Like, do you need a bottle? Do you feel bad about what's going on, and so you think everybody's just lying to you? Is that your solution? Grow up. Like, grow up. This is real. I hope that you are spared the tragedies that over 100,000 Americans have had to endure. All right. I guess I'll call it a day. So, because I can hear my baby tapping, rapping on my door. So thanks for hanging out. I have a podcast called Wired to be Weird. It's on iTunes and Stitcher. Wired to Be Weird, iTunes, and all the other ones. I have a Patreon if you're in a position to be able to help in these surreal times. I would appreciate it. Patreon.com/anthropoid. And I have a YouTube where historically, I have done about 15 to 20 minutes on a specific topic, and then I'll dive into the live conversation. You can find that by like searching for like Ian Anthropoid or like Anthropoid Brain, and you'll find it there. So with that, thanks for hanging out. Have a happy Sunday. Hope you have a happy week. Stay healthy, stay sane, and I will talk to you next time. See you guys. All right. That got a little intense there at the end. Okay, thanks for watching on YouTube. I appreciate it. If you're not subscribed, smash the subscribe button. Smash it with your mouse, though, because I don't want you to break your screen. All right, see you guys.